Good afternoon to you in Sydney. It's a pleasure to be addressing Lifeblood, the world's foremost collector of unpaid plasma for fractionation. And as an Australian, I am very happy with the great commitment that Australian jurisdictions give to plasma collection. Australia is probably the currently highest per capita consumer of Ig, immunoglobulin, outside the United States. Some between usage of immunoglobulin and demand of immunoglobulin. In this aspect, I would say that the concept of self-sufficiency, which is frequently mentioned in this regard, is not a very useful concept because self-sufficiency is simply a snapshot of usage. These factors, which you can see on this slide, affect usage. They include the increased capacity to diagnose patients, the increased survival thanks to the treatments and the key patient demographics, the widening of the evidence base for usage, and the increased patient aspects to care. It's important, as I said, that we distinguish usage from self-sufficiency. And in this regard, I introduce you to the concept of latent therapeutic demand, which was developed by Jeff Stonebraker in North Carolina some 20 years ago to project demand for factor VIII, which is now no longer relevant for hemophilia A in terms of plasma-derived products. Sufficiency can be assumed to be met when it approaches latent therapeutic demand, which is defined on this slide as the underlying demand that represents how physicians would prescribe treatment and how patients would comply with the prescribed treatment if ample supplies were available and affordable and access to therapy was unencumbered by issues other than evidence-based clinical need, such as financial constraints. In other words, this is basically a Christmas list for Ig, the concept of latent therapeutic demand, how much demand would be in evidence if all resource constraints and all diagnostic limitations were obviated. This concept has been used to estimate therapeutic demand for immunoglobulin for a number of indications, including the primary immune deficiencies and the autoimmune neuropathies, and I refer you to these publications. These studies model demand by extracting values influencing it from available sources, and then estimating the demand through statistical models of decision analysis. An influence diagram is first constructed, outlining the variables and how they interact to generate demand as shown. Each of the so-called random variables is associated with a level of uncertainty, necessitating a probabilistic analysis. This can be done using dedicated software and also spreadsheet packages which are available in most computer systems today. And useful outputs from the models include this kind of diagram called a tornado diagram, as shown on this slide. Note, for example, the importance of treatment frequency and disease prevalence in influencing demand in primary immune deficiency disorders, and the wide ranges for these variables extracted from the literature in this paper some years ago from Jeff Stonebraker and colleagues in the United States. The reasons for this variance are diverse and can include, for example, genetic factors, as is found, for example, in Finland for common variable immune deficiency, where genetic factors in the particular Finnish population necessitate a higher level of diagnosis and therefore Ig usage. Some apparent divergences in prevalence within the same geographical populations are less easily explained. For example, in Australia, the prevalence of chronic inflammatory demyelinating polyneuropathy, CIDP, when estimated using the criteria of the relevant clinical society, which are also the criteria used supposedly to issue the product, is between 19 and 57% of the prevalence estimated from actual immunoglobulin prescriptions, according to a MESAC report published about 5 years ago. These are important issues given the substantial contribution, about 30% of total usage, of CIDP to the total Ig usage in Australia. Using these models, the latent therapeutic demand for the primary immune deficiencies and the most important autoimmune neuropathies in the United States is about 230 grams per thousand population. This estimate naturally does not include other indications for IG, but it does indicate that for level 1, I emphasize for highest level evidence indications, the latent therapeutic demand exceeds by far the total usage of immunoglobulin in, for example, most of the countries of the European Union. It is not to be wondered at, therefore, that usage continues to grow briskly as the latent therapeutic demand is gradually approached. I now wish to address the other significant contributor to IG usage, immunodeficiency secondary to the treatment of hematological cancers. As may be seen, many of these conditions are associated with hypogammaglobulinemia. And as you are aware, this indication is by far the largest single contributor to immunoglobulin usage in Australia. The inclusion of this indication in the list of approved indications for immunoglobulin by the European Medicines Agency some years ago contributed significantly to increasing IG usage. I believe that this is also the case in Australia, where EMA regulations are adopted by the TGA. However, as you can see from this slide, compliance with the actual EMA recommendations, for example, dosage and duration of therapy in these patients, can be significantly at variance with actual practice. And similarly, practice across a range of countries with similar levels of healthcare can vary substantially, as can be seen in these figures for patients with chronic lymphocytic leukemia and non-Hodgkin's lymphoma, treated with immunoglobulin with and or without antibiotics. In parallel over the last 12 months of this particular study, which was published 5 years ago. Substantial variance between countries. And of particular importance, this study from last year suggests that the level of evidence for the duration of immunoglobulin therapy and the rules for its cessation tends to be of low quality evidence. Similarly, comparison of immunoglobulin levels prior to starting immunoglobulin replacement therapy and more than 6 months after stopping indicated that these were statistically significant, suggesting that immunoglobulin levels are well maintained after immunoglobulin therapy is ceased when patients are in remission. All this evidence contributes to the need to establish and maintain criteria for the cessation of immunoglobulin therapy in secondary immune deficiency. A recent important clinical study involving 7 centers in Australia and New Zealand and including Lifeblood investigators showed that clinical outcomes in patients with secondary immune deficiency were similar when patients were administered immunoglobulin or antibiotics prophylactically. It is to be hoped that this important finding is confirmed by larger pragmatic clinical trials involving practice in different countries. And this slide simply summarizes the study and its outcome in more details and concludes that a phase 3 trial is feasible, which I agree with entirely. I now turn to addressing possible alternatives to immunoglobulin for the clinical indications for which it is used. I draw your attention to the basic structure of the immunoglobulin molecule, broadly divided into 2 antigen-binding fragments and a crystalline fragment. I will focus first on the crystalline fragment, different parts of which have been exploited for their capacity to multimerize and to bind to the Fc neonatal receptor present, for example, in endothelial cells in the spleen, about which more later. These 2 properties are addressed in synthetic fragments in which alterations in the FcRn binding are generated, yielding molecules with a high affinity for this receptor. In the other approach, multimers of the Fc fragment are produced, yielding so-called stratomers, which interact with complement in ways to be shown. I will go through many of the following slides briskly. Here we see how Fc multimers can inhibit complement activation. downregulating inflammatory pathways. And in this mouse model, I emphasize mouse model, of an autoimmune neuropathy which is treated with immunoglobulin, not very frequently, but it is treated, particularly popular in Austria, um, although other drugs in other countries are used to treat multiple sclerosis. This ameliorates clinical symptoms and reduces injury to the nerves seen in this disease, again in mice. A particular molecule based on this principle of stratomers, therefore, was developed by the company Momenta and subsequently purchased by our own very dear CSL for $50 million US. Unfortunately, the first phase 1 clinical study for this drug was abandoned by the sponsor CSL because of, I quote from clinicaltrials.gov, lack of clinical viability. And all the other clinical trials for the drug, aiming to address in this instance ITP, were all abandoned, as will be seen by interrogation of clinicaltrials.org. So this approach need not trouble us any further. A lot of investment, but very little convincing benefit. In this overview of FC neonatal receptor physiology and FC neonatal receptor inhibition, immunoglobulin is bound to the FC neonatal receptor and is protected from lysosomal degeneration. Inhibitors to FC neonatal receptor compete for the receptor, inhibiting immunoglobulin binding and resulting in subsequent immunoglobulin degradation in the lysosomes. This is the basic mechanism. Much more complex in detail, but you don't need to know any more than that. And this approach has achieved significant visibility since one such FcRn antagonist, in the form of a synthetic Fc fragment engineered to bind strongly to the FcRn, was approved by the established regulatory authorities for the treatment of myasthenia gravis, a autoimmune neuropathy treated with immunoglobulin. This molecule, efgartigimod, difficult to pronounce these things, with a trade name Lifeblood, has been developed by Argenx and approved by the FDA using the pivotal clinical data to show that significant improvement was achieved in myasthenia clinical parameters with the drug. I won't go into these in detail, primarily because I don't understand them, but take it from me that the eminent investigators who developed this clinical trial developed this very good data. And in this very interesting and recent paper, a head-to-head comparison of the agent with IVIG showed improved clinical outcomes with the agent in impending myasthenic crisis. This is a very interesting and possibly historical paper showing that, in fact, the alternative is better than the original therapy. Of more significant implication for immunoglobulin usage, the agent efgartigimod, Vyvgart, has also acquired approval for CIDP on the basis of the data shown on this slide. CIDP, of course, is a much more important indication than myasthenia gravis in terms of the volume of immunoglobulin used. And it seems that Argenx are possessed of a significant pipeline with other molecules under investigation for other IG indications, such as multifocal motor neuropathy, MMN, and dermatomyositis, which are currently treated with IVIG. And we currently and eagerly await more clinical studies with these agents. Besides Fc neonatal receptor antagonists, a number of monoclonal antibodies directed against the receptor are attracting attention. Nipocalimab, developed by Momenta and acquired by J&J, is under FDA review for approval in myasthenia gravis. And the slide shows the clinical data forming the basis of the application for this monoclonal antibody, again showing significant improvement in generalized myasthenia gravis. This monoclonal antibody, rosanolimab, Bimolixizumab. Yeah, I deserve commendation for pronouncing that. Is marketed by the Belgian company UCB and in fact has already received FDA approval for generalized myasthenia gravis, based again on the clinical data shown on this slide. This recent meta-analysis summarized the various agents for which efficacy data is available. I leave it to you to assess the publication and decide which looks a better contributor. So far, we have reviewed alternatives for the autoimmune disorders, which absorb 30 to 40% of Ig usage. We frequently hear that such alternatives are not feasible for immunodeficient patients, which need a polyclonal supplement to their capacity to recognize and process antigens on pathogens. Clearly, Fc-mediated molecules cannot achieve this. But are there other approaches? Is this at all remotely feasible? Gigagen, which is owned by Grifols, has developed a technology whereby a polyclonal library of antibodies can be generated using recombinant technology. This was originally developed for generating hyperimmune antibodies, including a preparation for COVID-19, for which plasma-derived sources are scarce. Now I have to refer you to the detailed slide and the relevant publication in order to husband my time. They are available on the internet. And all these slides are available to your good selves because there's nothing here which is not public information. This data shows this slide shows data for a preparation rich in two antibodies which are very important for patients with primary immune deficiency, Streptococcus pneumoniae and Haemophilus influenzae, so much so that their specificity forms part of IVIG specification. The paper is available online for your review, but basically the preparation consists of clones for each immunoglobulin specificity, and you here have the data solely for the pneumococcus. The other agent has exactly similar data, showing high binding of the recombinant antibody compared to immunoglobulin, to IVIG. The authors from Gigagen, again, this is the same Gigagen paper, emphasize honestly that their preparation is not a replacement for IVIG, but rather supplements meant to increase the efficacy of IVIG. As they themselves state, a full recombinant replacement for IVIG would require much broader anti-pathogen activity. Nevertheless, in my opinion, this work suggests that the PID indication for IG is not impregnable to disruption, albeit in the future. So, as I approach the end of my talk, I would suggest that the continued growth of IG usage should not be viewed with the usual knee-jerk reaction of alarm and accusations of product wastage, off-label use, etc., but should be seen as the logical progression to full clinical demand. The decreased usage of other plasma fractions, such as coagulation factors and albumin, may put upward pressure on immunoglobulin prices, but so far, growth is being fueled by volume rather than price. Pressures on demand will ameliorate with possible alternatives, and in Italy, first-line treatment for many of the autoimmune disorders is now plasma exchange rather than immunoglobulin, in order to husband immunoglobulin, a policy which, in my opinion, is not very long-sighted because immunoglobulin is scarce, but doctors in Italy and nurses in Italy are even scarcer. Disruptive therapies may also influence future immunoglobulin demand patterns, as may the judicious and evidence-based use of antibiotics in secondary immune deficiency. So, to go back to dear old Vladimir Ilyich Ulyanov, otherwise known as NNE, plasma collection does need to continue growing, but only within a comprehensive and public health-based strategy taking into account possible future developments. In particular, we need to understand better how to measure and compare clinical outcomes and how to personalize treatment to individual patients rather than continue the clamor for more and more guidelines. The last thing we need is more guidelines. We have enough guidelines. And the public sector should view with interest the development of alternatives. Unlike and until, like hemophilia, plasma-derived therapies for the patients currently using immunoglobulin are honorably retired. And I thank you very much for your attention and hope to be able to answer any questions.